It is the 16th of February, 2018, and this is episode 88 of the Unseen Podcast. This is your host, Paul Carr, and joining me tonight is a special guest, physics professor and podcaster Chad Davies. Hello, Chad.
Hello, Paul. Thanks for having me on. It's really a pleasure to be here. I really appreciate the opportunity to join you guys.
Now, for those of you who have not had the pleasure of listening to Chad's podcast, The Scientific Odyssey, Chad, could you sum up for us what you do on the podcast?
Yeah, the podcast was originally conceived as sort of a discussion of the history and philosophy of science. And my original plan was to spend a few episodes, looking at a variety of what I would call big questions. And what's it's turned into is really long journeys through those big questions. So our first, major season was a discussion of the history and some of the philosophy surrounding an idea of the history of the atom. And that was really an interesting thing. I learned a lot doing that. And then the next series, which we're really just wrapping up now, is sort of, I title Finding Our Place, which is a discussion really of sort of the history of cosmology, starting from, in all of these, we start from the earliest ideas that we actually have recorded, which usually, or sometimes even earlier if we can, but, usually starts with the Greeks, though with the cosmology episode, we can go and look at ancient cultures, which is one of the things we got to do. And then we work up to the modern ideas. So it's, and when we get to the appropriate figures, I'll usually do some biographical episodes on those figures. And that's oftentimes, those will sometimes be one-off episodes, or there might be 3 or 4 episode series. And then we do a lot of discussion as is appropriate, try to fit it in where it's relevant, where we talk a little bit about the philosophy of science questions that come up during the discussion of a various idea. When we were doing quantum mechanics, we really spent some time talking about the idea of instrumentalism versus realism, which is something that came up again, doing some of the astronomical ideas, things like that.
Right. And I'm probably pretty much a noob on your podcast. I'm going to listen to about 30 or 40 episodes. So, you've done a lot of episodes. How many have you got up there?
I think I'm up over 160 now.
Oh.
I think
more than I listened to. I managed to listen to the one. I said I was going to listen to the rest, but I
Patrick, I haven't introduced you yet, so. Okay. Also joining us tonight are Sam Lichtenstein. Hello, Sam.
Hello from New York.
And,
Sorry, I was muted.
And Patrick Festa.
Hello.
Okay. Now, Sam and Patrick have both been on several times, so our audience doesn't really need much intro to them. So let's kick this off. Let's talk about. Sam, you wanted to talk about some topics. Why don't you start, and I'll follow up from there.
Well, I was just looking at Chad's bio, and I was wondering whether he describes himself in various terms, one of which is beer lover. And I'm wondering whether there are interesting science and or philosophy related to your interest in beer. But I also have some more serious questions if you prefer to go in that direction.
The beer thing, not so much a thing that happened as a science thing. It's actually, it's that standard. You go to college, you're going to drink a little beer. And I hated really, cheap, bad American beer. And so I managed to luck into growing up out in the Pacific Northwest and going to college as an undergrad out there. I lucked into the microbrewery revolution that happened out there in the 80s.
And, 20 years before the rest of us.
Yeah, it was awesome. And then, have sort of stuck with it ever since. So,
I can't. Sam, it was in the 80s. You were just too young to.
That's true.
I
was not imbibing at the time. Yeah.
There you go.
Sure. I'm sure there's plenty of interesting science there. Yeah. My first reaction when, based on, I'm not that well-versed in the podcast, but I have sort of, a passing interest in philosophy of science, history of science type issues. And my first thought was that a good thing to talk about would be kind of the most pressing, if you want to say philosophically or epistemologically interesting scientific issues of the day. And when I thought to myself what those were, well, actually there's a lot, but kind of from a kind of pure philosophy of science, how do we know what we know? What would it even mean to have a scientific theory type point of view? What stood out to me are kind of topics like string theory and cosmology, where the kind of the basic status about whether these scientific subfields are in good shape, whether they're telling us anything useful at all, is somehow a little bit more in question than in most fields of science. And something that especially stands out is this notion of using anthropic principles as a way to deduce scientific validity. So I thought that might be a fun thing we could spend a little time talking about.
Yeah, sure. I mean, I think when you talk about something, say, like string theory, or some of the versions of cosmology, one of the things that's really tough is when whether I teach a class at the college where I teach a history and philosophy of science course there. And when we spend some time talking about what makes a type of inquiry, a scientific type of inquiry, just, and that's that old demarcation criteria problem, or the demarcation problem is what it's sometimes called. What means we can call something science as opposed to pseudoscience, or just plain old inquiry, which is fine, but maybe not scientific inquiry. And so one of the things that I talk with my students about it is to the Karl Popper criteria, or criterion, I should say, which is the idea of falsifiability. That if you're going to propose ideas, hypotheses, models, however you want to call them, all theories, I think, is that it has to be testable and falsifiable. And that's probably, in the 20th century, one of the biggest criteria that was proposed, in the 30s and 40s, before you kind of got to some of the stuff that's more associated with modernism and all of that. And this is where some of the things that go on in some of the really, what sometimes get called cutting edge areas of physics, that's where those things run into some trouble. Really science, or is it more pure mathematics?
Right. I just to interject briefly, named Lenny Susskind, who's kind of famous as a colorful character, and
right.
I think associated with him is this what's the word? A disparaging term for philosophers of science. He calls them paparazzi. The falsibility is a criterion. POPPERAZI.
Right. And I mean, he's not the only one. I mean, Neil deGrasse Tyson said some pretty tough things. Hawking said some pretty tough things. And, as you can probably guess, I'm not a guy that kind of falls into that camp. I think, for me, I think that's a really important criterion. I think it keeps science honest. That doesn't mean that the work that's getting done other places, even if it isn't science, and I'm not prepared to say, oh, that's not science or anything, but even if it's not science, that doesn't mean it's in not valid work. It's not good work. It's not useful work. To sit there and say, if something's not science, it's not valid or useful, that starts to smack of scientism, that the only thing that's valid is science. And the only valid way of producing knowledge is scientific knowledge. And that's, again, I'm really hesitant to go to that place. I think there are a lot of methods of inquiry that are really valid methods of inquiry that address questions that science will just never be able to really address well. And so, if you decide that science is the only way to learn anything, then yeah, you sit down and say, well, I don't know if this is science. That's going to probably, rankle some people. But, to sit there and say maybe that, string theory doesn't produce any testable hypotheses. And so is it science or not? I don't know. That doesn't mean it's not interesting and it's not useful. And maybe at some point it won't produce testable hypotheses. But right now it's struggling to do that, and I think there are a number of people, scientists, physicists, philosophers of science, who have some real questions about whether we want to call it science, but that doesn't mean that would be like saying, sorry, all these guys doing mathematical work, none of the work that they do is valid or useful. And I don't think that's where we want to go with that. So.
Well, so this kind of takes me in a slightly different direction from what I anticipated, but setting aside this issue of whether the more mathematical side of string theory counts as science, but the broader notion of scientism as a term of derision. You feel about that? It's something that I feel I associate a little bit with the postmodernist left and kind of humanities department type attitudes, but obviously there's something to it that non-scientific forms of discourse. Because I guess on some level, look, like string theory, whether you want to call it science by some strict Popperian definition or not, whatever, it's obviously like at least sort of science, right?
Yeah, sure.
And so it's, the people who tend to decry scientism, I feel like I generally associate that with a slightly more deep-rooted critique of the scientific method broadly as something like the right approach to understanding the world. Somehow I feel like those two issues are a little bit potentially conflated in this discussion.
I think, I guess what I tell my students is science is really great about answering questions about the natural world. And that's because, again, some of the, I guess for me, what I would call demarcation criteria, having to be, to sort of look and say, okay, it's got to sort of be about the physical world, that you sort of have to have physical or naturalistic descriptions. You can't bring in metaphysical descriptions to explain what's going on. For example, I can't call something science and say, hey, I'm going to invoke some new supernatural description of that. That's not going to work, because nobody's going to sit down and say, gee, if I say, well, God said by fiat something happens, everyone's going to say, okay, now you're not doing science anymore. And the reason I think you're going to say that has to do with things like, that's not a physical thing. It's not a natural explanation. It's not observable, doesn't follow the rules of empiricism or something like that. So I think there are some things there that we can sort of say that, hey, if we're going to call something science, it's got to meet some basic criteria. Or, and this is, and I'm Fierbrand, I think, is the guy who says there's no such thing as science. I'm not going to go that far, but I do think you're going to limit science to certain fields of inquiry, which means there's going to be fields of inquiry, whether those are things like aesthetics or ethics or, law, what you might call legal theory, some things like that, that may be addressed by methods of inquiry that don't live inside of whatever we call science or scientific inquiry. And I don't think that's a problem. Again, to me, if we live in a society that says, gee, science is the only thing that can know something, boy, that really means that an awful lot of stuff, all of a sudden, we can't ask questions and then seek answers through those methodologies. And I'm personally uncomfortable with saying, great literature doesn't in some way allow us to sort of inquire about the human condition or the human experience or something like that. I'm not so. I understand there may be those who say, look, that's just all, a bunch of people sitting around talking, but I think there's more to it than that. And I think most people, if you sit back and just sort of do that gut check, will say, yeah, there's more to it than that. So on the other hand, the things that science does, where it does act, I think it is probably the most powerful way of arriving at information that's valid and reliable and trustworthy when we talk about the natural world. It certainly beats, if you talk historically, the idea of natural philosophy that would have existed, say, before people like Francis Bacon or Galileo or Kepler or, Vesalius in anatomy, some of those folks. What we had before then, where it's just a bunch of guys saying, oh, this is my idea about how the physical world works, and I don't actually have to look at anything. Obviously, we don't want to go there. So,
right now, yeah, I noticed that on your academic page, you taught, or you have taught a course on pseudoscience, the snake oil. I think that was. So there's another line there where we can cross over where we're not doing science and it's not valid. So what are your favorite rules of thumb for dividing the sheep from the wolves there?
Oh, that's really, it's a great question, and it's a really hard one to answer because, and I think, Sam, some of the things you were asking about and talking about there, I think feed right into this. And that is, what's known as the demarcation problem is still called a problem because it hasn't been solved, right? It's that idea of, okay, how do we demarcate science from pseudoscience? Snake oil, and, in that class, what I tell my students, I give them a claim and I say, okay, here's your claim. It can be anything from AIDS denialism to conversion therapy to homeopathy to whatever, and they have to go out and do some research. And I say, it can either be science, which means it's an accurate description of the natural world based in certain basic criteria, like, it has natural or physical explanations, things are observable and in some sense quantifiable, that, your explanations fit those things, that there has been some sort of evidence produced that supports the claims of the idea. I say snake oil is something that's definitively harmful. And that goes back to those old patent oil or snake oil salesmen that, that used to go ride around in the cart back in the 1800s. I kind of reference back. There's a great Mark Knopfler song about all of that. But the pseudoscience thing, and we talk a little bit about this or quite a little bit about this in the class. One of the things that I have my students do is I sort of use, and it's probably the best way, and hopefully this isn't too sort of out in the weeds, but Wittgenstein uses an idea in some of his philosophical thoughts, what are known as sort of a theory of similarities, where when like his example is you talk about games, right? Football is a game, and solitaire is a game, and bridge is a game, and lawn darts or something, I don't know, all of these things you might call games. Well, to sit down and try to say, okay, we're going to have a demarcation criteria for what's a game as opposed to what's not a game, that's tough to do. But what you can do is you can sort of build a class of similarities, right? You can say that these things have some things in common with these things, which has some things in common with those things. And so what I do with the pseudoscience approach is that's what I sort of do. I do this actually with some other things as well. We take a look at urban legends. We take a look at conspiracy theories in the class. We take a look at nutritional supplement claims, and then we go on to this idea of pseudosciences. And we build that idea that what you look for is you look for red flags. And we'll sit down and we'll lay out maybe 10 or 12 red flags and say, look, if one of these red flags pops up, that doesn't mean something's pseudoscience instead of science. But when you start seeing 4 or 5 or 6 of these things pop up, all of a sudden that should really get your, what was it that Sagan called it? The baloney meter, right? That should get your baloney meter pegged a little bit. And you should become really skeptical about those ideas. And that's sort of the way that, what's that?
The bullshit detector.
No, there's that too. That's the other way it's called, right? Yeah. But the thing is by sort of talking about that, what we can do is I can get my students, instead of trying to memorize some really hard, fast things that may or may not, 20 years down the line or 40 years or 100 years down the line necessarily be agreed upon, by using this sort of red flags approach, those are probably going to be pretty robust over time, I think. And they are much more broadly applicable beyond just maybe the narrow thing of, is chiropractic medicine a science, a pseudoscience, or a snake oil, or some combination of those, depending on which version of it you practice, right?
That's a good question. What's your answer?
I think, if you ask me personally, I think there are some things about chiropractic medicine that are probably scientific. I mean, to sit down and to recognize that, the structure of the skeleton and specifically the spine, and how that interacts mechanically. Yeah, there's probably something valid to that. But the idea that getting all of that lined up is going to unlock some sort of energy flow that's poorly defined that can cure diseases that have nothing to do with that, that's probably pseudoscience. And the evidence really very much shows now that things like rapid neck adjustments increase strokes by 30 to 40%. That's snake oil, right? That's actually going to hurt you.
Sure, but all that chi crap has been totally confirmed by traditional Chinese medicine, so I'm pretty confident in that.
Like I say, one of the red flags that you have is what's known as magical thinking, and it's just that that particular set of stuff. Boy, it pings all of that really strongly. So that's one of the ones that I give my students. That it's really interesting to watch my students interact with that, because oftentimes either they or people that they know have gone through and for a significant period of time may have used chiropractic services, and it really makes them sort of think about what they're doing, and it helps inform them in their conversation. If they have a chiropractic practitioner, they can have a conversation with that person about what is and is not appropriate care.
Right.
And I guess homeopathics might be another common one that a lot of people have encountered. And
yeah.
Maybe acupuncture as well, probably. Yeah.
I don't like to equate homeopathic with chiropractic, because homeopathic is utter bullshit.
I actually agree with you that there are some distinctions that can be drawn among these things.
I know, drinking water isn't that bad for you. That's basically what homeopathic medicines are.
Yeah, I was going to say, Patrick, I think, that's one of the goals in the exercise in the class, because one of the things I have students do is I have them actually present their ideas. And that's the thing we point out is that something like homeopathic, I don't even want to call it medicine, but you know what I mean?
Well, the thing is, the funny thing is that I actually had a couple of questions for you, but your introduction and Sam's questions basically already, answered my, in other words, my questions are no longer there. So I'm going to have to come up with a few more right now. Seeing as how you're bringing up homeopathic and chiropractic, for example, I've used chiropractors, whether or not they believe in what went on further into the their ideas might do other medical things that are sort of pseudoscience. The fact is that my problem was in my lower back. A chiropractor popped the damn vertebrae back into place, and I've been better since. Not that I'm perfect, but the point is that I was walking on a cane until now.
Yeah.
On the other hand, to make the ultimate comparison, homeopathy, fucking bullshit. Excuse my French. You know what I'm saying? It's like there's a big difference between.
But yeah, actually, I mean, to push a little bit further on this, like it strikes me as a. Sorry, I'm getting an echo now. I don't know if other people are, but it seems like a difficult class to teach, partly because a typical student, what you're interested in pressing on to, I guess, like the median student, is kind of a like it's almost like a life skill, right? Being able to approach scientific sounding claims in a sort of sophisticated way with critical thinking, basically, right?
And that's exactly, Sam, what the class is actually. The class is built as a critical thinking colloquium. That's the whole point of the class. So hitting on that idea is exactly
that's like
what we're trying to go
really
with.
admirable goal, and totally something that you don't want to undermine by introducing unnecessary subtleties. And yet at the same time, from a philosophical point of view, it strikes me that some kind of some of the interesting juice lies exactly in the subtleties, and where you get into these kind of realms. And maybe chiropractic is like actually a pretty good example of this. It's like there are, or I think of certain claims about global warming science, about the validity of claims based solely on general circulation models, that computer models that have a certain amount of information and they make certain predictions, and you can have certain confidence in some claims derived from them, but what degree of confidence is actually a sort of not totally trivial scientific question. And what's another I'm sure there's a lot of examples of psychology as well, or these fundamental, like the fundamental physics examples are very stark somehow, because it's like not even clear in principle how an experiment could ever be done,
right,
just with the laws of physics as we understand them, that would resolve some question about like inflation, or like, can you detect things beyond our light cone or something like that? Certain aspects of the universe that seem like they're almost in principle undetectable to us. And that's like sort of, you get off in these sort of abstract weeds that it's hard to even understand the terms, but there are actually these kind of somewhat more down to earth scientific questions that are like somehow like a little bit on the boundary between science and pseudoscience. And you don't want to confuse the students by studying these vague cases, but they're kind of the most interesting cases.
Yeah, well, ways. I think that studying the easy cases first may be the right way to get introduced to the area. Some of the things I'm most interested in at various times have been accused of being pseudoscience. For example, SETI or astrobiology. There's no evidence, no hard evidence, which the astrobiologists will tell you is true, of life on another world right now. That has not stopped them from doing a lot of research on that possibility. In fact, if you look up the SETI Institute, most of their scientists are doing astrobiology, not SETI. Only a small fraction are doing SETI. Or Jason Wright recently argued that SETI is a form of astrobiology, but and I think he has a good point. But I have heard, and I know the previous generation of scientists, this is more likely than the current generation, but astrobiology, pseudoscience, it doesn't have anything to study. And yet you have all these young scientists who are absolutely in love with astrobiology.
I'm sorry, but to me, I'm not a scientist. I'm a science enthusiast. But to me, the term astrobiology is a real term. It is a new form of science that is, as far as I know, not being a person who was actually in college or anything like that. As far as I know, it was the idea that they want to study the possibilities of life in other environments outside of our solar system.
No, actually, well, in our solar system,
Yeah, but
Real science. I mean, that's not pseudoscience.
Yeah, but
Pseudoscience
Patrick, think
to me-
about being a physicist interested in nuclei of atoms back before Oppenheimer did his gold foil experiments, right? I mean, there were people.
That was Rutherford.
Rutherford, yeah.
seriously.
Oppenheimer did other
Rutherford,
stuff.
Yeah, Rutherford, yeah, sorry.
The word
Yeah,
pseudoscience
yeah.
is it encompasses the utter nonsense. Like for example, the homeopathy.
Well, but there is these borderline. There's these difficult borderline cases, Patrick.
We're not talking about astrobiology. That's a real term. That's a real.
No, of course it's a real term.
Yeah, but there's a famous example in pure math of a guy who wrote a thesis on some obscure thing in topology, and he had to go back and rewrite it because during his dissertation defense, somebody noticed that the set of things that his theorem applied to was empty. So like there was actually you could prove that there were no examples of the thing that he proved the theorem about. And so not be like pseudoscience in the sense of being inane or nonsensical, but it could still lack reference in the world, which might be equally problematic.
What bothers me is the label that it incurs. In other words, astrobiology as a term in and of itself, if I want to use proper English, is a term that encompasses real ideas in science. That is this, trying to study something that is a possibility, whereas science or the phrase pseudoscience encompasses the nonsense. And for anybody.
Well, I mean, is it just nonsense?
To tag astrobiology as a pseudoscience it disturbs me.
Yeah, Patrick, I think the problem's harder than that. I don't think it's just nonsense. I mean, it's easy to pick out nonsense, right? It's harder to pick out things that sort of wearing the cloak of science. And I agree. Astrobiology is a real science, or it's becoming a real science. And I think SETI's a real science too.
Paul.
Sure.
I was just going to say, I think the word you use there, some of the things that I've heard used for things like astrobiology are things like an emerging science, right? That may be a term that's actually a better term than either pseudoscience or calling it a full science, simply because, like other fields, I mean, there are times when fields emerge out of other,
That's
other sorts
term.
of
Emerging
things.
science is an excellent term. Pseudoscience is an absolute swear word against,
Right. And I mean, that's, and then, I think the other thing you sort of have to recognize a little bit too, and I'm going to get to a point with this, is that there's also flim-flam, if you want to call it that, or something that you can think of, if you want to use something more pejorative and stronger, you certainly can, but, and that's where maybe something like homeopathy, right? Where there is just absolutely no basis in any attempt to sort of establish its validity scientifically. It uses magical thinking and irreproducibility and all of those things show up. That's not just pseudoscience. It's just absolute flim-flam.
Exactly.
Right?
Exactly. That's why I think of pseudoscience as the first thing I hear in my head when I hear pseudoscience, I think of homeopathy.
Yeah. But a lot of the same techniques are used in social psychology.
Well, I see that. Well, right? No, and that's one of the things that's really interesting about having the conversation between science and pseudoscience. And Paul, your comment about there being gray areas is really relevant here. And that is you look at astrology versus astronomy, they share an awful lot in terms of things like measurement and interest in, motions and all of those things. And then there are certain red flags that show up in astrology that don't show up in astronomy. Probably the most important is one of the later sort of conversations about demarcation, which has to do with, do you adapt and solve new problems, right? And that's a later criterion that shows up in after Kuhn's work.
So I'm sorry, Chad, to interrupt, but you see, where I draw the line, I'm coming from a person. Again, my vocabulary isn't college level, but I'm coming from a line where as a science enthusiast, I understand where astrology started, The ancient Chinese, for example, had some of the best star charts in their time. I mean, we still use some of them, and granted, this is where the line is drawn. Granted, they were doing that because they were doing some pseudoscience, but in that endeavor to do their pseudoscience, they had to have really accurate charts. So they were actually doing some real science, but that doesn't make astrology a real science. It just means that they were actually doing some real work and mapping.
No, absolutely. And I mean,
that's where the line is drawn. In other words, what were they doing that was real? They were actually mapping. What is not real? The rest of it. You know what I'm saying?
Well, no,
I can.
Should we put that in historical context? I mean,
no, exactly. Yes,
they had access to a lot less information than we do. They were actually trying to figure out how the Earth and cosmos interacted, and they didn't know any better. And so their ideas were possibly, and we probably don't have access to most of the ancient ones, but we're probably pretty sophisticated. Just didn't hold up under examination later. But yeah, I don't think an astrologer in ancient China is equivalent to an astrologer today.
In a sense, yes, and in a sense, no. I mean, so the thing is, whether you look at Chinese astrology or you look at Mesopotamian astrology, which is the astrology we sort of see nowadays in, sort of our Western context, really is more strongly Mesopotamian than it is Chinese. But both are similar in that they're just trying to figure out how to make predictions of the future, right? They're doing that thing that we all want to be able to do, which is, if this moving object in the heavens lines up with this thing in the heavens, well, the last time that happened, the king got overthrown. So,
and there's probably some also explicit, at least pseudo-religious motivation involved, like some sacred texts or whatever associate certain astrological alignments with prophecies or whatever, right? I mean,
right, and I mean,
like somehow the motivation for the observations you're interested in.
Well, but there is some reality here, right? I mean, when a certain star comes up on the horizon at sunrise, right, then it's planting season or something like that. In other words,
no, and that's exactly right.
The seasons, it's not that easy to understand that the seasons and the weather and the climate are not somehow linked to the stars.
Right.
And so why not everything else? It's not that unreasonable a presupposition.
Well, not only that.
I agree. Like in the ancient times, it was hard to separate that, but we now know enough, and it's a shame that people still believe in some of this stupid stuff. We now know plenty to. I don't like even to use that word plenty. I don't know why I just used it, but we know much more in order to separate the nonsense from the actual work that was being done, and it's a shame that the nonsense is still proliferating.
I think it's kind of interesting to draw a contrast between a case like astrology, where it sort of feels pretty strongly in retrospect, like we can draw a clear line between the scientific and pseudoscientific precursors, to a case like alchemy, where at least for me, it feels like you can't draw any such strong line. Basically alchemy blended almost imperceptibly into chemistry, and
Well, actually, it's kind of funny. So Travis Dow has a really great podcast called The History of Alchemy. I don't know if you guys have seen it or heard it, but if you're interested in, finding out a little more about the subject, he does a nice job of sort of going over it. But I talk a lot about alchemy in my history of the atom, because one of the things we really spend some time on is chemistry, and how does chemistry develop? Chemistry, the way we think about it, doesn't really show up until Lavoisier. But you can look back at the work in alchemy that Newton's doing. You can obviously look at the, Boyle's The Skeptical Alchemist, and it starts looking a lot like chemistry. And there is
probably a fair amount of practical metallurgy, I would guess, that's also has some fairly sophisticated chemistry involved.
Right, and actually probably the bigger influence from what I've read is actually practical medicine. Is actually a bigger influence in this area, than actually even metallurgy is. Though metallurgy is important in this, right? But you have, and the other one that turns out to be pretty important is what we now call pneumatic chemistry, but just sort of understanding gases and how they interact, and a lot of those guys again were working from beginning in practical medicine. But the thing that's just really interesting about that is it's not a very long period of time where you get the shift where people are thinking, okay, alchemy's the deal, to where you get to the point where you say, no, it's not alchemy. Alchemy is kind of flim-flammy, and what we were looking at is chemistry by the time you get to Lavoisier, you know?
Well, you might
So you can actually see the historical scientists drawing a fairly clear distinction between what they saw as flim-flam and what they saw as legitimate chemistry research?
Yeah, you really can. I mean, and now that period of time, you know, looking back now, time compresses the further back you look. And so, you know, at the time, it probably seemed more subtle. But now that we look back, you know, it's not that long a period of time, you know, and you see similar things going on in astronomy.
Well, you know, alchemy is one of those particular emerging sciences, as we use the term, as you gave me the term earlier, where several hundred years ago, you know, they were trying to figure out how things worked.
Yeah.
And while they have a lot of things wrong, they were getting the idea that.
Yeah, one of my favorite guilty pleasures is watching YouTube videos of amateur chemists who like to refine scrap jewelry into pure gold. And they're just using very standard techniques. You know, they're forming aqua regia from a certain mixture of nitric and hydrochloric acids and things like that. It's all stuff that all the alchemists would have known, like it would have been back totally second nature to them. And it's like, you know, it wasn't important enough to make it into my high school chemistry textbook, at least, you know, but it's pretty interesting stuff, actually.
Yeah. I mean, it's not as you know, alchemy now is a bit of a joke, but you know, it goes into the magical thinking. But in the day, it was more of a science than anything else was in those days. You know, it was they were trying to figure out how things worked. It was before they understood the atom.
Well, and I think, you know, Patrick, you can go farther back than that. And this is one of the things, you know, I right now I'm not teaching my typical colloquium, science, pseudoscience, snake oil. The colloquium I'm actually teaching is a history of the scientific revolution colloquium this semester. And so one of the things that we talk about is, you know, you got to sort of establish context. And so we spend some time talking about what I think of as sort of the classical mind and then the medieval mind. And alchemy lives so strongly in the medieval mind, going back into the classical mind, because it really has its roots back in some of the writings of Plato and Aristotle, and then that gets developed later. Is, you know, this whole sense that you're talking about a culture or a mindset that is entirely what I would call non-scientific. It's very much what we would think of as natural philosophy, where you would sit down and the idea of using empirical techniques, that idea of making observations and those having greater validity or greater the reliability than, say, the use of reason or the assertions of authority. In the medieval mind, that would never have been the case. You would say, okay, the use of reason or Aristotle's authority would be the thing that would carry the argument, something that nowadays in the modern mind we look at and we just think is just bizarre. But at that time, you know, so when the alchemist came up and said, well, we know from the writings of, you know, Jabir that, you know, the great, you know, Arabic chemist or alchemist, that this is the case, everyone said, oh, well, yes, of course, that's the case. We know that all metals are made of, you know, combinations of mercury and sulfur. And, you know, the more sulfur you have, the more gold or coppery the metal will look. The more mercury you have, the more, you know, more silvery things are going to look, you know, and that sort of thing.
Yeah,
that's
not some. That was before they understood the atomic number. You know.
Yeah, I just, you know, I mean, in a sense, even the idea of how you define an element, you know, I mean, that in some ways is, you know, the sort of the thing I would say demarcates chemistry from the other stuff is you get a new definition of what an element is. And that idea of the old Aristotelian 4 or 5 element model, you know, and that Lavoisier is able to show that that model is absolutely false. Once you do that, you know, now you just sort of are broken free of the shackles of Aristotelian medieval thinking and all of that. Lavoisier takes you in, he's got conservation of mass. Dalton almost immediately thereafter, you know, is going to come up with that idea that, oh, wait, all matter really is. And I can show with experimental data, show that all matter is atoms moving in a void, combining in certain ways. His atoms are very different than the atoms we think of now, but it is the basis of what we think of as modern atomic theory.
So do you think that those guys, Newton, Lavoisier, did they think of themselves as in such a strong tension with their forerunners, or do you think they thought there was more continuity? I'm partly kind of trying to probe the question as to whether how pseudoscientific our science is likely to be viewed in 100, 200 years.
Yeah.
Like.
So I think the thing that's kind of interesting is it depends on who you look at historically, right? I think you look at someone like Newton, and I think there have been
he was a whack job.
Well, yeah, and I mean the thing is whether he's one biography of him calls him the last sorcerer, which I think is a quote out of something that was written at the time. A couple of other, Gleick's biography sort of portrays him in the very much, he's one of the very last medieval, or what we think of scholastic thinkers. But then, I don't want to quite call him a disciple, but that's maybe not the worst word to use. Halley, when you look at Halley's biography, Halley is entirely what we would think of as a scientist. There is no sense of him having that medieval mindset at all. Mm-hmm. Copernicus, for example, very clearly is a scholastic thinker. You can tell by the way he writes and the fact that he doesn't want to publish. His mind is in what we'd call a manuscript culture rather than a printing press culture. And yet the guy who actually ends up printing his great work, on the revolutions of the spheres, Rheticus very much is somebody who's much closer to what we think of as a scientific thinker. Kepler and Galileo, we can probably look at as scientific thinkers. Brahe, that's a little harder to pin down, so it sort of depends on the individual you look at.
It makes me wonder if there's a relationship with whether we would identify these people. Newton seems clearly to me to be someone that we would recognize as a prodigy. He had this kind of completely new mathematical perspective on things. He seems to have been very prodigious in his both his personal, he probably was a little bit on the autistic spectrum, right? He seems to have had an unusual personality in many ways, and so I wonder if there's a tendency for in retrospect, maybe we conflate less conventional ways of thinking with kind of mysticism or kind of less modern or conventional scientific approaches. But that's complete speculation on my part. I don't know.
The thing that I think would probably be true is you go back to pre-scientific cultures, people who perhaps, were more like, say, a Newton or a Dirac, who's another classic example of somebody who might have been on the autism spectrum if there had been that at the time, those guys would probably have been looked at like mystics in a pre-scientific culture. And,
it seems fairly natural. Yeah.
Right. And their insights into the behavior of the world might have seemed somewhat otherworldly to somebody who was perhaps deeply ensconced in a very, medieval or,
religious.
Religious or pre-scientific mindset. Yeah. You know,
I have a question. It's a little off subject, but being you, the historian, the scientific historian, there was a time, speaking of alchemy, there was a time where they were trying to turn lead into gold kind of thing. And we know
right, the whole philosopher's stone thing. Yeah.
Yeah. We know nowadays that the atomic number is I don't, what is it? A couple of protons away. So the idea here is that they were actually on the right track, but they were never ever going to be able to accomplish what they wanted to do. But in a sense, they were sort of track of thinking, so can you give me like a historical date, like when that was happening?
So a couple of comments to that. So when you look at alchemy, and then this is where Travis Dow's podcast is probably a lot better than what I've done, because I really focused on just the idea of the atom rather than some of the other developments. But we know alchemical thinking certainly is starting to show up around the time of Aristotle. So, you're talking about the time of Alexander the Great, maybe. So you're talking 3rd century, 4th century BC in Greece and in just around the Eastern Mediterranean. Yeah. Now what we think of as that sort of transmutation idea, Patrick, I think that idea develops a little later. Okay. So, and I haven't been able to nail down a date on that. The sense I get is probably that's 10th, 11th century AD, but it may tie back into some of the Islamic philosophers from the Islamic Golden Age, which, that starts 8th century, runs through 10th, 12th century.
Wow. That's confusing.
Yeah, I mean, so
let me ask you this then. Let me ask you, let's since that's so confusing, with the idea that they were on the right track.
And again, that was the other comment I was going to say.
But obviously, they were never going to be able to achieve it because we were talking about fusion and fission. Given that idea that they were on the right track, when do you think, as a historian, when they were closest to it before we actually found out that atoms are the number of the protons determines the actual element and things like that. When did that break? When did that finally say, well, okay, we can't do this?
And this is, I think, Patrick, the thing that makes this a really hard comparison to make is you might look at it and see similarities in some of how they thought and some of the ways sort of a modern chemist would think. But one of the things that's fundamentally different between the way we think now and the way an alchemist would have thought, alchemists didn't think there were atoms the way we do. Okay. Alchemy didn't use much of an atomic model. Alchemy used this idea that matter is continuous. There is no void. And what you're trying to do is you're trying to say, and, without diagrams and all of the sort of things, I could hold up little charts or something, but without all the diagrams, it's a little hard to describe. But, Aristotle said there are those 4 classic elements that we've all heard about, earth, water, air, and fire. But he also said there were qualities of matter, and I'm, since I don't have them right in front of me, hopefully I'll get them right here, but it was moist and dry and hot and cold. And so you could change one, if you were looking at something, you would look at a piece of matter and you would say, okay, well, this piece of matter is the way it is because it has, it's 40% earth and 12% water and this percent this and that percent that. And if I want to change it into something else, what I need to do is change some of the earth and the water. And by changing that percentage mixture, I would change what the thing was. I would transmute that object from one thing into something else.
Well, who was the first one to say, okay, this is wrong?
So the first guy that really is able to say that those elements don't exist is Lavoisier. Yeah, I mean, Lavoisier comes up, and I can't remember which one it is for sure, but it's either water or earth, and he says that's not an element. That's made up of other stuff.
What was the approximate date?
So Lavoisier, it's going to be late 1700s. He loses his head in the French Revolution, so he dies in 1794. So I want to say he does his work 1787, 1789, somewhere in there. Yeah.
So we're talking hundreds of years.
So how does the Democritus atomic theory fit into this? Do these guys know about it and explicitly reject it for some reason? Or did they forget about it? Or
So no, it's lost to Europe. Yeah. I mean, so
it's forgotten somewhere between ancient Rome and the Renaissance.
Yeah, absolutely. So the thing is that it's, and I'm going to not remember the date on this exactly, but it's 1500s. There's a Roman philosopher by the name of Lucretius who's written a poem called De Rerum, if I get that name right. I think that's the name of it. And that poem is lost. And then it's rediscovered in the 1500s in a library of a monastery. And it's the first real document that says, here's atomism. I mean, the idea that there might be atoms is sort of out there a little bit if you read the right Islamic philosopher, but to come from a Roman philosopher, a classical philosopher, natural philosopher, that's about, I want to say 15, 16, something like that. And it becomes a point of debate between several, what we would think of as early scientists, Descartes, the guy named Gassendi, some of those guys. But that the discovery of that document is a huge bombshell that gets dropped into the late Renaissance, early scientific revolution period.
Right. Yeah. And Descartes in particular was pretty into the idea, if I recall correctly. Like he had his little vortices or whatever, right? And,
and so, yeah, I mean, the thing is that that's one of the things that's interesting about Descartes and a couple of other thinkers is their atom. I have an episode called the corpuscular atom, and their atom isn't what we tend to think of as a Democritean atom in that it's hard or Dalton's atom, which are hard, indivisible with liberty and justice for all spheres. But instead they're these sort of, like you say, they're these vortices, and you can penetrate, and they're kind of soft and corpuscular in a way.
Well, it's an appealing idea that I think it was actually resuscitated in the late 19th century. There was a mathematician named Tate, who was an early knot theorist who, presaging some more recent string theory things, had this idea that different elements relate to different knottings of some corpuscular little knot string things.
No, and I mean,
which is a great idea, but I don't think it's true.
Well, no, I mean, the thing that's really interesting, I think it's Letterman sort of talks about this. Leon Letterman, the Nobel Prize winning physicist and particle physicist, he really talks about that idea that what we call an atom isn't what the Greeks meant, right? What we tend to think of as atoms, are these sort of collections of subatomic particles that do have some ability to interpenetrate, or at least be kind of squishy-ish through the interaction of, whether it's chemical bonding or whatnot.
And they have interesting properties because they have structure.
Right, exactly.
Yeah.
Whereas the Greek atom, in other words, not split or not divided, atom, that's what that literally means. That would be more what we'd think of as our fundamental particles, things like electrons and quarks, things we can't split, at least not yet anyway.
Okay.
So, yeah.
Do you have a sense of what the kind of experimental basis was for Democritus or the early atomists? Sorry, if this is too far afield, Paul, we can move on to something else. But
there are arguments. I don't have them in front of me right now, Sam. So I apologize.
I'll go back to your podcast, then. That's fine.
Yeah, the philosophical atom, and I think maybe the Greek atom, something like that. I spent some time talking about some of the Democritean arguments for an atomic model of matter.
Nick Nielsen, who's watching live, has a question. He says,
"Hey, Nick.
Given what you said earlier about the origins of scientific medicine and its relationship to pseudoscience, do you have an opinion on Heraclitus and the relationship of early medicine to alchemy?"
Oh, Heraclitus. I've only dipped into Heraclitus a little bit. He was really an interesting person to study when I studied him for a little bit about that. I mean, again, Heraclitus probably is one of those transitional figures between a medieval mind and a scientific, or maybe, a scientific revolution mind, from what I've been able to tell. And his work, he's the first guy to start thinking about things like conservation of mass and trying to make measurements. And while his work isn't always great, it's a step very much in the right direction, and it sort of pushes medicine, along with some other writers at the time. It pushes medicine in the right direction. And I mean, the difficulty with medicine, my students just did these papers on the Islamic philosophers, or Hakim as they were called in their culture. And several of them were, whether it's Avicenna or Al-Razi or some of these guys, they were really, really, really great folks that pushed medicine forward. You don't get another big push like that until you get, like I say, Vesalius's On the Fabric of the Human Body is the great anatomy text, right? That's made possible by the fact that there's a printing press. Heraclitus is able to do some things. And if I remember what I read correctly, he's actually heavily influenced by some of the work of Copernicus and some others. And so that sense that you have these transitional figures that go beyond just saying, well, Galen said or Hippocrates said, and so that's what must be the truth, to actually we need to start poking around and making observations of the physical world and doing some of those sorts of things. We look at a lot of what Heraclitus did at the time now as pseudoscience, but when he was doing it, that's pretty cutting edge, looking towards scientific stuff. It's just he's working, especially in his field, at the very early stages rather than at the much more mature later stages.
And
right?
He had shitty tools. Right?
What's that?
Until microscopy, medicine was like a really difficult thing to study, right? I mean, like he just didn't have a lot to work with. Well, in retrospect, right?
Well, I would say in the sense of how we might see a modern version of medicine, which would be, cell biology, molecular biology, those kinds of things, encoding information in DNA, viral theory, germ theory, all of that. Absolutely, Sam, that's correct. But at the time, the big thing was they were really looking more at macro structures in terms of things like, how does blood circulate? How do you actually figure out how the heart pushes blood around, or
even like the physiology sort of.
Yeah,
right? Yeah.
you see, Chad, that's one of those, again, the word pseudoscience was injected. And I'm looking back as if perhaps I was several hundred years ago. And this, I don't know this Pericles, and I'm woefully ignorant of the history. But now that I've heard you and listened to what you were saying, you use the term pseudoscience to explain, like it sort of delved into the pseudoscience, and I can't see that. In other words, today it would be.
And I think, Patrick, that's actually my point.
At the time, like you said, as you mentioned, it was the cusp of the ideas that were being pushed forward.
Well, if I can interject you briefly on this, I think like when you're talking about pseudoscience.
Hang on 1 second. In other words, Pericles obviously was on the right track to start thinking about what is real science. Yeah. So I can't, if I were living in those hundreds of years ago, I would not call that pseudoscience at the time. But instead, I would consider him as a big thinker, and even if he was brought up and only knowing what they knew of those days,
I think the point is that
it wouldn't be considered pseudoscience at today.
That terminology of pseudoscience has so much value judgment loaded into the word, and it's difficult to like think about it without injecting kind of like the teleology, like the purpose that we care about science for into how we evaluate what the scientific output is. And so like, if you think about like medicine, for example, until like, I don't know, 75 years ago, doctors killed more people than they saved, right? From like a social good point of view, it's hard to call it anything but a pseudoscience until like extremely recently in medical history. And yet, from a kind of broader scientific perspective, it's clear that people like Pericles and even Galen, they were making incremental steps towards what we know now, and it all kind of
but
it's a spectrum. My point is that it's a spectrum, and that like our value judgments will tend to bias how we think.
I give a lot of credit to the people.
The terminology.
I give a lot of credit to the people of hundreds of years ago, because they didn't know any better, as was mentioned before. Who made a step forward into thinking real science.
Patrick and I would agree 100% with what you just said. I thought I had tried to say that, but if I misrepresented, I apologize, because you're absolutely right. I mean, somebody like Pericles,
no, you didn't represent. You actually gave me the idea to say that.
Yeah. So the idea, I mean, at the time, I mean, he's we call it, pardon the pun here, but he's bleeding edge, right? Yeah, I mean, the thing that's really interesting is, his colleagues at the time had criticisms of his work that were actually valid criticisms, but the same thing could be said for scientific work today, So, and I think, in this, I'm going to seg here a little bit, but I think, Sam, maybe you brought this up in the sort of the discussion thread in preparation for the show, which is, when we start looking at maybe, what we're doing today, if we look maybe 100 years ahead and think, okay, what are those guys going to look back and see? The thing that's one of the things that's really interesting, whether it's string theory or, some of the ideas in multiverse cosmology or some of those sorts of things that right now are not particularly testable. They're not testable in what we would think of as our formulation of, the standard model or lambda CDM model of cosmology and particle physics, right? But we certainly know those models have deficiencies. We know they do, and so it may turn out that in 10 years or in 20 years, all of a sudden we have a similar sort of revolution in physics or revolution in cosmology, much like happened around, the cusp of the 20th century when we came up with quantum mechanics and relativity, and we fundamentally changed from classical to modern physics. And we'll look back and we'll say, okay, well, those guys had approximations in their descriptions of reality that were very good up to what they understood. But then, in 2042, so-and-so reimagined how we think about this using this mathematical tool nobody had thought about using in that way before. And next thing we know, we have more accurate approximations of physical reality in terms of mathematical modeling or physical ideas and concepts or whatever the case may be. And I don't think anyone's going to look back at this time and say, gee, they were doing pseudoscience. What they're going to do is they're going to say, hey, the science that they did was limited maybe by the observations they could make, or they hadn't had a breakthrough in terms of this way of seeing or that way of seeing, much like we would have if we went, say, back to, 1850 and, Lord Tom, or, William Thomson, i.e. Lord Kelvin, doing work in what we would think is standard classical physics models, trying to model the sun, but not being able to because he doesn't understand nuclear fusion or something.
Right.
Okay, that's a pretty nice answer to the physicists of today. But to put you on the spot a little bit,
Okay.
Do you think that there are scientifically important constraints imposed by philosophical considerations in thinking about what such future fundamental physical breakthroughs might look like?
If we look at the past, the answer to that question almost has to be yes. The breakthrough for Einstein in coming up first with special and then general relativity, those breakthroughs aren't nearly as much in new physical ideas as casting aside the Newtonian idea of absolute space and absolute time, right? That's Newton's great advance over, a lot of what had happened before him, is he creates this absolute space and this absolute time. Well, all of a sudden, along come guys like Lorentz and Poincaré and Ernst Mach, and they're sitting down and they're making philosophical arguments that absolute space or absolute time don't actually exist. You can't observe those things. Those are just frameworks that Newton's imposed to make his mathematical models describe reality correctly, and they did up to a point. Well, once Einstein sort of realizes, look, what if I say I've got a choice? I either have to say the speed of light isn't constant in every reference frame, even though we measure it that way, or I have to get rid of absolute space and absolute time. What happens if I say the speed of light is in fact a constant in every reference frame, because that's what we measure, and I throw out Newton's idea? What he does there is he overthrows a philosophical assumption about the nature of space and time, right? And that creates first special relativity, and 10 years or 15 years after, I guess 10 years after that, leads him to general relativity. Similar progressions happen in quantum mechanics. When Heisenberg sits down and says, gee, we really don't know what an electron's doing in its interaction with the nucleus of an atom. All I know about are transition matrices. And again, this is a very instrumentalist point of view, heavily influenced by Ernst Mach. And so he says, let's get rid of that description entirely and only do those matrices, and he comes up with the matrix mechanics description of quantum mechanics, right? Again, throws off a philosophical assumption from Bohr and Sommerfeld. So my sense is, if there's another great advance in physics or, cosmology, what have you, it may very well, again, historically, it would seem to be almost certain that we would make significant philosophical changes in terms of, how we see the structure of space and time or something along those lines, and the problem is that right now we can't necessarily see what those things are, but there may be some, 12-year-old right now who's, doing something, and, in 10 years, we're going to hear about this kid all of a sudden saying, wait, what if we do this thing? And all of a sudden, all of the issues that, we know we have where we can't unify gravity with the other three interactions or whatever, that all just resolves out.
That's exactly what from the beginning of this conversation, what I'm getting at. And again, and I apologize for my lack of vocabulary, but the idea of what is real science and what is pseudoscience. In other words, all these discussions about overthrowing Newton's, because Einstein said, what if we just made light, the speed of light, constant, things of this intellectual concepts. These are all valid scientific ideas. To me, what bothers me the most, and I'm going to use a really throwback, example of what is absolute stupid, pseudoscience, is like, I don't understand that, therefore the earth is flat kind of thing. In other words, there's a difference between disagreeing or finding a new concept, even if it's mathematical or only mathematical, or mathematical plus some observation, or the lack of the ability to observe. It doesn't matter. The idea is that it's an intellectual exercise. But when you throw away the intellectual exercise and just start saying, oh, I don't understand this, therefore, God kind of thing, that to me is what pseudoscience is, what pisses me off, basically, when it comes to the thing.
Yeah, I mean, and again, this comes back to, what we think of, and this, Sam asked right at the beginning of the show here, the idea of, what's a demarcation criteria? And, maybe you throw out Popper's criteria that it has to be testable and falsifiable, which, a number of philosophers of science and a number of scientists have said, hey, maybe that's a little unrealistic. But at some point, you got to sort of have something that says, okay, wait a minute, is this science or is this something else? And I mean, you call it pseudoscience and you can do that, and it's hard to do that. But if you do it in a purely theoretical conversation, you can do that, not assign pejorative meaning to the term. Instead, maybe reserving something like flim flam for the pejorative sense. But there is a sense where, whatever's happening. I mean, if we look at the, say, standard model of particle physics, it does an enormously incredible job of describing a vast array of observed physical phenomenon.
Right. And now, in other words, don't label it. Just say, is this a valid question? Is this a valid a path of investigation?
Well, but
even in asking the question, you risk saying no to stuff you don't want to say no to. Like the people most likely on some level to come up with these new philosophical insights. The person I'm thinking of is a guy named Nima Arkami Hamed, who's a string theorist working. And I watched a lecture of his, which I'll try to put in the show notes, about sort of trying to resolve some sort of basic puzzles in quantum mechanics with kind of a new perspective. But by venturing into that philosophical territory, you intrinsically have to get close to the edge of what's correct science, like what's bullshit or what's legit. It's a very difficult line to walk, I think. And
well, sometimes
I
sometimes
bristle
it's not
at the idea that we can draw fine lines between what's okay and what's not.
I like to use absolute bullshit as an example of how you can, I make the joke about the Harry Potter's dark detectors, the sneaker scope, my bullshit detector is well refined these days. An example of an absolute bullshit detector would be NASA is hiding this truth from you. These kind of advertising things is an immediate red flag.
But Patrick, those are slow fish swimming in a shallow barrel.
Absolute silly, But the point is that if you can use that as a gauge, if you can say that this is my voltmeter, my bullshit detector meter, and realize you can calibrate it to be more refined than that. Obviously, the example I just gave you was the absolute bottom line, of bullshit.
Well, it's not. I think actually the problem with the flat earthers is that there's conspiracy theorists.
I'm just saying that if you can sense the nonsense, right? That kind of nonsense is obvious.
But yeah, that's too obvious.
If you can refine your detector to sense the not so obvious.
Yeah, I mean, flat Earth. There's a long way between flat Earth and well, gosh, what's a good example?
I mean,
the JFK assassination.
Well, no, I mean, the thing that's interesting, I mean, you look at things, nowadays, probably, the one I sometimes like to talk about is the idea of conversion therapy, right? The idea that perhaps, someone's sexual orientation can be changed through some various forms of counseling up to, electroshock therapy, right? Which is horrifying. If we're going to electroshock therapy, that's actually a really relevant thing that, in our modern culture, in certain segments of that culture, has a real sense, at least in some circles of scientific validity.
Yeah.
The question is can you sit down and really sort of say, okay, is that science or is that pseudoscience apart from your, personal opinions or your, strongly held beliefs about, whether, sexual orientation is permanent, and that's something that whether it's genetically encoded or socially created or whatever actually, that may be.
And what I think is a very interesting but extremely controversial twist on a related question is I've heard exactly one person. He's a very controversial thinker, so I won't say his name, but put forth a putative scientific hypothesis about homosexuality, which is that it could be, whether you want to call it a pathogen or not is a politically loaded question, but like there could be a microorganism that affects whether there could be what might naively be described as a disease that, and in evolutionary context, maybe it's appropriate to think of it as a disease because it affects relative reproductive rates. That affects brain development in a certain way that causes homosexuality. It's not actually a trivial thing to falsify. And the example that he gives is that certain diseases like rheumatoid arthritis, which are, I think it's widely believed to have a genetic component, but it was unknown in the old world until contact with the new world, because apparently it was mediated by a new world pathogen that causes a certain region in the brain to be vulnerable to some hormonal transformation that affects how arthritis manifests itself. Like, there are extremely subtle and difficult to detect relationships between the human body and various pathogens, which can cause all sorts of strange physiological and behavioral. I think syphilis is another example. That was
I'm sorry, Sam. I'm sorry. I have to interrupt you because coming from a straight person, I have a problem with the problem is that you're labeling it as a disease, and that's the problem.
It's intended to be value neutral. My point is a mediated mechanism as opposed to let's say, purely an external biological mediated pathway for a particular sociocultural behavioral pattern. Is that in a suitable?
Well, why couldn't you falsify that easily? You just find the same pathogen in straight people. I mean,
I hate
some pathogens are very difficult to identify. For example, the pathogen
Star Trek version video
with rheumatoid arthritis has not been identified yet.
Yeah, but that has nothing to do with.
But there is epidemiological evidence to believe that it is still due to a pathogen.
I hate to use a Star Trek reference on this, but I have to, because there was one actual Star Trek Next Generation episode where there was this alien who they were both male, female, that sort of thing, and Riker actually kind of like fell for one of them. In other words, it is almost incumbent of the society to label a gaiety or transgender or any of the above. And again, I apologize for my non-knowledge of this, because I'm a straight person. I'm trying to be careful about this. It seems to me that it's always somehow labeled some kind of disease.
Yeah.
It's like
the only point I was trying to make is that science is hard.
It's like Chad tried to mention about
politics.
I think we've gone far enough down that road, guys.
Can I add one thing that sort of brings us back to history and philosophy of science?
Thank you.
Sure.
Yeah, no problem. I think the thing, Sam, though, I mean, this guy can make, he's proposing a hypothesis, and okay, that's great. And it sounds like it's a scientific hypothesis. But it is incumbent upon him to prove the validity of his hypothesis, not upon the rest of either the scientific community or the LGBTQ community to disprove his hypothesis, right? And that's the thing that I think is it's valuable to understand. Whatever his hypothesis it is, whether it may be or may not be offensive to us, whether it may be politically correct or not politically correct, whatever the case may be. If he's proposing it as a scientific hypothesis, he assumes the burden of proof. And I mean, I think you understand that, of course, but it's worth saying in this conversation. And
Sure.
if he's able to provide evidence that supports that, then we take that up, I think. And this is where, you again, getting back to some of the stuff we talked about at the beginning of the show, this is perhaps where other methods of inquiry become important. Ethics, things like ethics or legality or some of those sorts of things, and I'm, that's a topic for a completely different show, perhaps.
We could probably have you on every week for a year and not run out of topics. I do have one more question.
I'd love to.
I have one more question from Nick Nielsen. Actually, I have two more, but I think we're only going to have time for one, so I'm picking the first one. He says, would you care to compare Mach's instrumentalist point of view with Percy Bridgman's operationalism?
It's this one of those places where I don't know enough about operationalism to be able to answer that question, I'm afraid. I wish I did, and I'll go look into it and see if maybe I can come back with something. But the sense of what little I understand about operationalism is, I think there are some connections, but I don't want to go much farther than that. Sorry, Nick. I wish I could answer your question a little better. It's just, this is a place where I'm pretty ignorant.
Okay. We're getting to the point where it's time to wrap up. And I like I said, I think we're not going to run out of topics with Chad. He's if you go listen to his podcast, The Scientific Odyssey, there's well over 100 episodes. They go deep into history, philosophy, personalities, biographies, even the instruments that were built to understand scientific principles. One of my favorite sections was the section about 19th century and early 20th century astronomy, and the ladies at Harvard who made all these great discoveries, peering at photographic plates for hours on end. And
the first hidden figures, right?
Yeah. The glass universe ladies. Yeah.
Yeah, absolutely.
That's got to be a movie soon, I hope. But
it would be nice.
Because they were, these women did amazing work in spite of not being taken that seriously by their male colleagues. So, if you want to know more about that, listen to Chad's podcast. He's got hours of that information for you. So I'm going to give Sam and Patrick a chance to make one last comment, and then we'll get back to you, Chad, and you can tell us how we can find out more. So, Sam, any last thoughts?
I'll close with a recommendation in the tradition of the Unseen podcast. I will embed a link to this in the show notes, but it's a talk by Nima Arkami Hamed called The Doom of Spacetime, Why It Must Dissolve into More Fundamental Structures. And I think it's a great example of what we were discussing before about the philosophical ways in which somehow new insights could be broachable via coming up with a new perspective. It's very optimistic talk, but it also touches on some kind of pretty interesting modern research in fundamental physics about, roughly speaking, kind of new approaches to doing traditional quantum field theory, Feynman diagram computations that seem like they might be a new perspective and let us rethink some of our traditional ideas about quantum mechanics. So, I'll include the link in the show notes so that people can check it out.
Okay. And Patrick, how about you? Patrick, you're muted.
Oh, you're muted.
There you go. Okay. Paul, your sound is getting muted. Anyway, I came into this podcast thinking that I was going to ask Chad about anti-jump cannon and his podcast.
I have to wait enough for another time, Patrick.
Carr actually supplied me with that link and everything. And I'm not going to say unfortunately, because fortunately we actually talked about a lot of other good things. But I'm going to say that I'm going to recommend Chad's podcasts on the the anti-jump cannon stuff. Paul, you're going to help me out here with the actual name of that podcast.
I think I have a link somewhere in the. Yeah.
Yeah, I'm sure I don't have to provide a link because you already provided it for me, so I'm sure you can provide it again. I'm going to recommend those podcasts because I was listening to it and I was actually coming into this thing thinking I was going to ask Chad about the star formation and things like that, but we actually got into other great conversation about something else completely different.
That's what we do on this
definitely
podcast, Patrick.
listen to Chad's podcast.
It's something completely different. Okay. Chad, where can we find more information about you and your podcast?
So just you can find my podcast at all the or at least most of the general places you find podcasts. So I'm out there at Apple Podcasts. I'm at Google Play Music. I think I'm on Player FM now, which is really nice. I'm getting a lot of downloads out there. I'm on iHeartRadio, and it's just the Scientific Odyssey. And like I say, we've got 3 seasons. The first season's fairly short, where I just sort of talk about some of the fundamental ideas of what makes science, just to sort of create a basic vocabulary. We've got a season on the history of the atom, and then this Finding Our Place. And as you all have said, that's where those episodes on the Harvard calculators, as I like to refer to them, including, everyone from Williamina Fleming through Annie Jump Cannon and Henrietta Leavitt up to Cecilia Payne Gospochen. All of those ladies, just the work that they did is remarkable. And I have to say, one of the things that's really interesting is, while my inspirations originally aren't them, when I did really get into sort of realizing that I wanted to do astrophysics as sort of a life, career, whatever kind of thing, their stories really, really inspired me. When I was a senior in high school and my freshman year in college, reading their stories and finding out the kinds of things that they did, and just realizing that we could learn about stuff we would never be able to go to by looking at the light that came from that stuff. I have to say, I think that's one of the crowning achievements of the human intellect, which I understand in some ways is very, when you think about whether it's a standard model of particle physics or whatever, and that's just such amazingly overarchingly beautiful stuff in some ways. The simplicity of being able to look at light and understand things is, to me, just, I don't know. I just get really excited about that. So I have several episodes on those sorts of things, including some of the basic physics concepts like Doppler effect and all of that. So if your podcast listeners would like to go out there, I'd love to have them visit the podcast. We have a website. It is the scientificodyssey.typepad.com. We've got a Facebook page. So you just search on the Scientific Odyssey out on Facebook. You can find the page. You can like the page and just sort of keep up with what we're doing. I have a Twitter account, Well, we'll have
links
Davies.
to all this stuff in the show notes.
Yeah. But anyway, I just, anyone that wants to come out and be a part of the crew of the Odyssey, we'd love to have you join us.
Yeah, no, I recommend it too. And thanks, Chad. Been good. I think we could have gone on for hours and hours and not run out of topics, but we have to cut it off here. But if anyone is interested, the show notes for this episode, which is episode 88, will be at unseenpodcast.com. And you can go there and we'll have all kinds of linkage there, including links to Sam's favorite stuff and whatever else is relevant to this episode. So, again, we'd like to thank Sam Lichtenstein, Patrick Festa, and Chad Davies, our special guest. And once again, that's the Scientific Odyssey. It's out there, easy to find. And I recommend you subscribe to that. I recommend you subscribe to us if you're not subscribed. Please, you can subscribe to us on any podcast aggregator you like, including Apple Podcasts or Google Play. Pocket Cast is what I use, and we're on that one too. And so by all means, that's unseenpodcast.com. If you have questions, comments, anything you want to add, you can add them right there at unseenpodcast.com on the blog entry for this episode. That's episode 88. So it is still just barely the 16th of September 2018, and that's it for episode 88, and we'll see you in 2 weeks for episode 89. And thank you and goodbye.